In January 2018, at the Denver Central Market, Jon, Chris, and Rich were planning a business venture around training for Docker. Jon and Chris were explaining Docker to Rich, and he said, "I wish I could have recorded that." And the idea for Mobycast was born. In episode 1, the three of them tried to recreate that conversation on virtual machines versus containers. They got most of it right, but there were some inconsistencies and holes. The Mobycast crew admits, "We didn't prepare as well as we should have for that first episode, and frankly, it shows." More than 80 episodes later, the crew has learned a lot and are ready for a do-over. In this episode of Mobycast, Jon and Chris kick off a 4-part series on virtual machines, containers, and how they compare. They correct old mistakes, fill in the gaps, and dive a whole lot deeper than before. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts Jon Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Before we get started today, I'm so happy and so proud to be able to announce that we have a sponsor. So Mobycast is no longer ad-free. But our sponsor is one that we really do care about. We use Circle CI, and we've talked about Circle CI in a previous episode. I'll link to it in the show notes. So I just have this to say. This episode is brought to you by Circle CI, the continuous integration and delivery service used by companies like Twilio, Intuit, and Tinder. CI/CD is so important for keeping teams building. It's all Circle CI does. They focus on creating powerful, flexible CI/CD pipelines so that you and your team can focus on doing what you do best. Whether you're a company of 5 or 500, Circle CI can build, test, and deploy your Linux, Windows, and Mac OS projects from GitHub and Bitbucket in their cloud or installed on your servers. And anyone can sign up and start building for free, since Circle CI gives both private and public projects 1,000 free build minutes per month. Sign up and start building for free at circleci.com. Welcome, Chris. It's another episode of Mobycast.
Hey, Jon. Good to be back.
Yeah, good to have you back. Today we're going to go back in time and redo episode 1 of Mobycast. And it'll probably be more than one episode this time, because virtual machines versus containers is not something that you can talk about briefly. That's so important and such a big topic that I think it's going to deserve at least 3, but maybe even 4 episodes to really get deep into the stuff that's driving cloud development today. And this, Chris, maybe you can talk about this a little bit. This is part of why we want to do this, is because of some feedback we've gotten on the show.
Yeah, absolutely. So, we love feedback. It's good to hear from folks that are listening to these episodes that we're making, and we want to make sure that they resonate with you and they're useful and provide value. So we do look at the ratings and reviews, and one. So it's nice. We have quite a few nice reviews out there, and yes, those are fun to get, right? Yeah, don't get me wrong; those are fun to get. About like, wow, you guys are just awesome, right? You're the bee's knees. But we did find one. I think it's actually in the Canadian store.
Canada.
For iTunes.
Being real with us.
Yeah, the truth bomb. And so had a review there where the reviewer essentially was saying, look, listen to a bunch of your episodes, and the first episode, it's kind of obvious you didn't do your homework, right? Like you actually had a few things inconsistent. There were some holes there. And, in later episodes, it's obvious you guys did do your homework and got better. So not really great feedback to hear in a way, but also at the end of the day, the dude is right. Like he was absolutely 100% correct. And it actually is great feedback. And I think, part of that is like when we first sat down to do the first episode of Mobycast, really didn't have any idea, like, where was this going? And I think if you had told me, here it is today, where we're recording episode 81, would we be doing that many episodes? Back when we first started doing this with episode 1, it's like, I don't know if I would believe you. But
I would have gotten anxiety if you had said that to me.
Yeah. Right. So let's just start with one, and you know, it was a learning process for us too, as well, and also very busy with, you know, just holding the fort down with you know, our day jobs, if you will, and it was perhaps a little bit too off the cuff. So.
Right. I do have one other point to make about the Canadian review, though. Like, he gave us 3 stars and he said we weren't very good, but he also outed himself for having listened to the whole thing. Would you do that? Like, my goodness. Like, if I think something's not that good, I stop. I don't keep going.
Yeah, I mean, there's a little bit of a contradiction there, right? To say, like, hey, you know, not really, this is not so great of a podcast, yet I've listened to, obviously, multiple episodes, right? Like, many episodes. And yeah, I mean, like, I think most people, if you're going to give you might even give a podcast only like 5 minutes before you're like, you know what, it's not working for me. So to sit through, to listen to hours worth of content, you know, I mean, so something's going right there, right?
Must be doing a lot of driving or something, or just out of other tech podcasts. But, you know, giving him a hard time, we really appreciate the feedback. And if you ever want to meet us in person, I'll buy you Horton's coffee or whatever they drink up there in Canada.
Indeed, yeah. I have a Tim Hortons story that I will save for some other day, right? We have a lot to cover here with VMs and containers and breaking them all down again. So maybe we should continue on with that.
Yeah, let's get into it. So today we'll mostly be talking about VMs, less about containers. Let's just really understand what VMs are all about. They are what drive the cloud. There is no cloud without VMs. So maybe, Chris, you can kick us off there.
Yeah, and I mean, I think just can't stress that point enough, right? Like, VMs really led to the creation of the cloud. Like, you just can't do it without it. And it's really one of those key core technologies that we live with every day. And we throw around this term VM, you know, every day, but really understand like what that is, how it works, the different flavors, the different technologies that are around it. Like, a lot of folks are a little sketchy on the details there. So we want to dive into and kind of really understand that. And I think it'll be helpful for all of us, right? In as we work with cloud native software and spinning up VMs and it will lead a lot of value and kind of understanding like, okay, what is the difference between VMs versus containers? And spoiler alert, there's this new thing called micro VMs, which is a combination of VMs and containers, and, you know, just where the technology is going as well. So this is going to be just really understanding VMs at a fundamental level is just crucial foundation knowledge. And so it's worth spending some time on.
Right. And it's just like in our episode or our series that we did on encryption, the first episode kind of laid a lot of foundations, and then we built on those foundations in the following episodes. So today we'll be laying some foundation.
Absolutely. So let's get started with that. So first, let's talk about the types of virtualization. And really we can talk about it 2 broad types. So one is full virtualization. And this is typically what we're referring to when we talk about virtual machines, so VMs. So this is full virtualization, which is a mouthful. This is simulating enough hardware to allow another operating system to run on it in isolation, right? Unmodified. So it's virtualizing everything. So we talked a lot about this in episode 1, where it's virtualizing the entire machine, right? It's virtualizing the hardware and the software, right? So to that running guest OS, it doesn't know the difference. It doesn't know that it's actually running inside software, inside of this virtualization.
Yeah, you can think of back in the day, like if you had a Windows operating system, it literally came in a box that you could buy at Best Buy. You could take that thing and install it, and it has certain expectations of what the hardware is going to be, and those would all be met by full virtualization.
Indeed. Yeah, in fact, back to the device driver hell.
Right. But I think that's a good way to think about it, because if you could take the disk out of the box and install it. Like, you know, even though you're not installing it directly on the machine, you're installing it into the virtual machine. That's a really helpful way of thinking about it. Then the software doesn't know any better. It doesn't know the difference.
Oh, exactly. So one of the key fundamental enabling technologies for full virtualization is something
Say it in
called
Spanish.
Yeah. Okay.
Let's do it in all the different languages.
Yeah.
Full virtualization. It's hard for me to say too.
I know it's could we just say the V word? So a big component of this is going to be the hypervisor. And the hypervisor is kind of what allows this full virtualization to happen. We'll talk more about that as we get further into this episode. But just keep in mind, hypervisor is going to be really important for the full virtualization. And some examples of full virtualization technologies are things like VMware, Parallels, VirtualBox, Microsoft Hyper-V, KVM. There's just a bunch of these things that we talk about with virtual machines. So that's full virtualization. The other type of virtualization is operating system level virtualization. And this is actually what containers are. Containers are basically the virtualization is happening at the operating system level. So here the resources of the computer are being partitioned via the host OS kernel. And the guest OSs, and by the way, so we're going to talk a lot about host versus guest. And so host is the native operating system running unvirtualized on a machine, and the guest is the virtualized OS running in whatever technology it's using. So host and guest. So in the operating system level virtualization, those guest OSs, they're going to share the same running instance of the OS as the host. So the operating system kernel is shared. It's the constant across these things. Versus in a full virtualization environment, that's not the case. There's separate. That makes sense. Separate kernels, right? So operating system level virtualization, some core technologies there that enable that. Things like namespaces and C groups. And when we talk about containers, we're really going to dive deep into just how that stuff works. But some examples.
I'm so looking forward to that because I think that's where maybe we were a little weak in episode 1, and where I'm still to this day I'm a little weak. So I'm going to be depending on you, Chris, to teach me.
Yeah, we'll make you strong.
Good.
Yeah, and so some examples there for operating system level virtualization implementations. Obviously Docker, Linux containers, LXC, and the original technology here is FreeBSD jails, which came on the scene in 2000, I believe it was. So almost 20 years old now, but didn't take off as much.
That's so wild. It's like came on the scene in 2000, just before virtual machines got popular. Not that virtual machines weren't already around, but they weren't really popular in 2000. People weren't really saying much. VMware, I don't think was really a big company at that point. So yeah, it's interesting.
Yeah, well, I mean, and that's a whole nother part of the history is like why VMs even were created. What were some of the things that, the conditions that caused them to explode. I know for me personally, back in the late 90s and early 2000s, VMs were like the reason for doing those was like for developer reasons, where you wanted to be able to test different versions of an operating system, or you're writing some code, you want to make sure that it runs on this version of the OS. Like I was at Microsoft, we were writing client code for Windows and needed to make sure it ran on both Windows 95 and Windows 98. Windows 2000.
Or for us at SourcePerform, the other one it wasn't cloud stuff. It was like, here, sales team, this is a VM. We're installing it on your laptop, and you can start it up, and it's going to be right where you want for your demo to be running. It was like magic for them.
Before that, we had a dual boot, which was just horrible, right? So there, you instead of having virtual machines, you just spliced up your hard drive into partitions and had different OSs installed on each one of those partitions, but you had to choose at startup which one you wanted. So glad that we now have virtual machines.
Exactly.
Then later it was all about like, how do you more effectively run, take advantage of your resources? How do you have big beefy servers, but run multiple virtual servers on that to get the ideal density and efficiency of using the CPU and memory and whatnot, right? And that's what then really drove the cloud. And from there, it was off to the races.
Right.
So let's focus now on the full virtualization. So this is, again, the virtual machines. And we talked about hypervisor as being kind of core to this. And so let's kind of peel that back a little bit. So hypervisors, they're also known as a virtual machine manager, or VMM. And really what the hypervisor does is it's responsible for creating and running virtual machines. It's a process. It separates the OS and applications from the underlying physical hardware, right? So it's that layer between them. And multiple virtual machines running on the same physical machine, they're going to share virtualized hardware resources. So again, it's the thing that is responsible for allowing for that virtualization of the machine itself, of the hardware, so that those guests don't know the difference.
So I get that idea, and I think we're going to answer my questions coming up, so I'm going to save them, but just know that I have questions about this. I kind of get this idea that the hypervisor is managing my machines, my virtual machines, but I'm like, oh, I've got some questions. So let's keep going, and let me just see if my questions get answered, and if not, I'll ask them.
Sure. Yeah. So this might be kind of helpful. There's two types of hypervisors. There's type 1 and type 2, right? Really, really creative with the names, but kind of makes it easy to keep track of them as well. So let's talk about type 2 first, because type 2 is actually the for us, it's not as interesting. And so with the type 2 hypervisor, this is running on top of the host operating system, and it's running like any other app, actually, right? So you have your host machine with the host OS, and then you have this type 2 hypervisor that's running kind of basically as like an application.
Yeah, and it's its own program, its own process. Yeah.
Right. And then you have your guest OSs running on top of that, right?
That's so weird, right? Like, that's so weird because the operating system is installed directly onto the hardware. It has direct access to the hardware. It runs a program that then lets other operating systems get installed into it that see the hardware virtually. Mm-hmm. That's weird.
Yeah,
that's weird. And that was one of my questions. That was exactly one of my questions. And maybe you knew that was going to be one of them. Mm-hmm. It's like, where is this hypervisor? Is it in the chip? Is it, something that gets installed somehow in RAM? Like, where is this thing? Mm-hmm. So yeah, the type 2 hypervisor you're saying is just like any old software that runs on the operates system.
Yeah, with some special hooks,
special capabilities,
calls, right, and everything like that. But it is very much important to read. Like, it is running on top of the host OS as a separate program that you install. So some examples of this are VirtualBox and Parallels. And so you can think of these as more, these hosted hypervisors, these type 2 hypervisors, really more for personal use. This would be something, again, you install on your MacBook or install on your Windows machine. You go get VirtualBox, and now you can run different operating systems and whatnot. But you're going through this hosted hypervisor, which doesn't have nearly the kind of capabilities and access to the hardware and the ability to more effectively use the resources of the system. So, like, these type 2 hypervisors, you have to specify when you create a guest OS exactly how much memory it's going to get, and how much disk space it's going to get. And that is just going to be carved off. So if you have 16 gigs of RAM on your machine and you create 3 guest OSs and give them each 4 gigs of RAM, you're only going to have 4 gigs left over for your actual host. And then if you created another one with, 4 gigs of RAM, another guest, then you're out of memory. Versus with the Type 1, it has much more flexibility where you can actually, it's more dynamic in its resources. You can actually do the same kind of scenario, but it's only going to use memory that as it needs it. So you're not pre-allocating those resources. So there's just more flexibility with Type 1, more efficient use of the hardware. And that's why Type 1 hypervisors are what we'll see, running on servers in the cloud and in the enterprise.
Well, you've said now that Type 1s seem to give me some more flexibility and are better and are running in the cloud, but you haven't really told me what they are yet.
No. So let's dive into that. So,
okay.
so these Type 1 hypervisors, they're also called native or bare metal hypervisors. And these, for the most part, they run directly on the host hardware to control that hardware and to manage any guest VMs.
Okay.
Something to wrap your head around is that they're an OS themselves, right? These hypervisors. So it's a very simple OS, right? And it's a simple, you can think of it as a simple operating system. It's running on top, it's running on that hardware, that machine. And it really only exists for you to spawn VMs. Okay. So this is, so it's, again, just, you can imagine like you boot up a machine and instead of, going into like a Windows OS or a Linux OS, instead it's like, this is the hypervisor OS. And it says, what do you want to do? Like, well, I want to go create VM or whatever like that. Or here's how you interface to me and talk to me and whatnot. For the most part, again, with these Type 1 hypervisors, the physical machine that the hypervisor is running on, like it serves only for having VMs on it.
Right. So it knows how to talk to the hardware, but it's not going to worry about things like users and other things like that operating systems worry about.
Right. I mean, it's purely, you think of it as an OS for VM. And so whatever whatever it needs to do with VMs, like back them up, create them, delete, destroy them, those kinds of things. Like that is what it's focused on.
Cool.
And so things like some examples here of Type 1 hypervisors are the Zen hypervisor, which is an open source project that's been around for quite some time and quite popular. There's Microsoft has its Hyper-V hypervisor. And then, VMware, big player in this space as well.
Their hypervisor, it looks like you have it here, is called ESX or ESXi.
Yeah, they have quite a few different products and flavors. I mean, VMware has definitely been in this space for, almost 20 years now. And so there's lots of different flavors, but that ESX is one of them. I'm actually trying to picture like you're setting up a data center, you get a machine, you put it on the rack, you give it access to a boot disk. That boot disk might already have like this hypervisor installed on it, and boom, it comes up, and then like here's a bunch of VMs that you can, on some other disks that you can have access to and start running. Those would be like AMIs, right? Like go grab me an AMI. Yeah, and we'll talk a bit like, okay, what does AWS do in this space, and what are how are EC2s implemented, and what are the hypervisors that they're using there, and what do images look like, and how's an AMI different than another VM image and whatnot. So
so we'll get to that in a future episode, but yeah, I guess that was the thing that occurred to me is, okay, so these things run on the bare metal. Who installs them? Where do they come from? Does every computer have them now? Is that just what we're running now? Like even my MacBook that I'm sitting in front of right now, is that running a bare metal hypervisor these days or not? Like, I don't know.
Yeah. And, no, for your MacBook's not. It does have a hypervisor in it. So So kind of said, okay, there's type 1, type 2. And so type 1, it's the hypervisor's running directly on it's bare metal, right? It's running directly on the hardware. It's kind of you can think of it as an operating system in and of itself. And they really only exist to allow your machine to run virtual machines. So, in that particular case, like you would know if you had a type 1 hypervisor, because like whenever you started your computer, you'd get a kind of a very boring screen saying, okay, what do you want to do? What VM do you want to run? So, and then type 2, we said, okay, these are kind of like applications you go and install, and you'd launch them, and then you'd say, okay, what VM do I want to run? And now you're, again, it's pretty prescriptive. There has been a bit of some cross pollination here. An example of this would be, so an easy one to talk about here is Hyper-V from Microsoft. So Hyper-V is the Microsoft Type 1 hypervisor. It comes with Windows Server, and by default, it's not enabled, but you can go in and enable it by adding a role in Windows, or there's various different ways to enable it, right? So Hyper-V you can install or enable in Microsoft Windows, but it still has the host OS of Microsoft Windows, right? So it's a little bit different, right? It's not like this pure, like what we talked about type 1, where it's like there's this VM operating system, right, called the hypervisor, and that's all that's on there. And then you can install your you can have whatever VMs you want running. So if that was the case with Hyper-V, like you would just have a computer, you'd install Hyper-V, and then after that, like if you wanted that computer to run Windows Server, you'd then install that as a VM on that machine, right? And it's not how Hyper-V works. Okay.
I guess what I had been picturing, like when I was wondering, are these things on my machine already? Is that what just runs these days? Is like kind of like, installing Microsoft Windows might be doing something like installing a hypervisor and then installing Windows and then just kind of scripting, this is what happens. The hypervisor starts and then it starts the Windows VM. And like you don't get a choice, like you don't get that screen you're talking about because it's just automated. And that's what I had been kind of wondering if that was happening. Because I swear I've seen like the word hypervisor in the startup script of my OS's, like literally on my OS that, my computer that I'm sitting next to right now. But maybe I haven't. I don't know. Just that word feels familiar to me from the boot sequence.
Yeah, I mean, like it's there by default in modern versions of Windows now. So part of this is like, okay, what is a hypervisor and what do you need it for, right? You need it for its whole purpose is to virtualize the hardware so that you can run virtual machines. And so you want that there when you have the need for running virtual machines, right? But if you don't have a need for running a virtual machine, then you don't need it. So this is one of the reasons why Hyper-V is implemented the way it is. There's, for the most part, like most people, like in your laptop, your desktop computer, you don't have a need for running a VM. So like me, I'm running, I have a MacBook, for the most part, I don't need a VM until I run Docker. And then when I run Docker, I do need a VM. And so the Docker implementation on my MacBook then takes advantage of a hypervisor to launch a VM in which Docker can run. And we'll talk about that more in the container when we talk more about containers. But think of it as like for the most part, hypervisor is going to be something that's going to be pretty explicit of a choice of whether or not it's actually enabled and you're running virtualized software through it. Does that make sense?
It does, and it kind of answers the thing that was also going on in my head, which was, if VMs are super, super efficient at this point, like you can turn around what you just said, like I don't have a need to run a VM, to be like I don't have a need not to run a VM. Like why not? Like why not just always be running a VM? Because maybe if everything was always VMs, maybe like the abstraction and dealing with VMs kind of would be more same, right? Like you wouldn't need to have a difference between, like you would just be always in a VM, right? And so everything is a VM. There's no such thing as pure operating system that talks directly to the host hardware anymore. But it sounds like we're not there yet, and maybe we'll never go there. But I was imagining in my head, we could be there. Why not go there? Why not have everything always be a VM, even my MacBook Pro OS X software? But it sounds like we're not there.
No, and if we were there, there would probably be for implementation benefits of people writing software and hardware, and less for users.
Exactly. Exactly.
Right. So,
because then everything looks the same. Like everything's a VM to the people that are writing code, writing programs.
Yeah. But there's, again, because you have something sitting between it, there's always going to be some performance penalty, right? So it's, if you don't need to be running if you don't need virtualization, then like you don't want it. And again, that's again, like why, like for the most part, your laptop and your desktop computers, like you're not running a virtualized guest OS, but in the cloud, like this is all that those servers run, right? There is no host OS on those machines, right? It is just that hypervisor. And the only reason why those machines exist is to run VMs. So totally different kind of use case and how they're used.
Cool.
And like I said, there's it gets a little blurry with like, do you have a host OS with type 1 hypervisors? We talked about Hyper-V, how that's a bit of a mishmash. KVM, which is for Linux. It's kernel-based virtual machine extensions, and this is also a type 1 hypervisor, but it requires Linux, right? So Linux is a host OS, so it's blurring the line there a little bit as well. But for the most part, type 1 bare metal native hypervisor, and that's really kind of what we'll be talking about going forward, since that is the predominant one in the space that we're in when we're running cloud software.
Great, makes sense.
Yeah. So wanted to talk a little bit about protection levels and rings, and this is one of the things that we talked a little bit about in episode 1 when we were talking about virtual machines was, how do you virtualize the hardware? And there's these things in the processors. I know that they have some capabilities, and you can sometimes in the past you had to enable that in BIOS, and what's going on there. And so it's kind of helpful to understand again, like this virtualization of the hardware, how it's done, and by talking about these protection levels, the ring. So this applies to the Intel family of CPUs, the x86 family of CPUs. The CPUs themselves, they have this range of protection levels, and they're known as rings. So there's essentially 4 levels of rings. So ring 0, that has the highest level of privilege, going down to ring 3, which is the lowest level. And so ring 0 having the highest level of privilege, that's where your kernel or the supervisor is running, right? And so, by the way, the kernel, another name for kernel is supervisor. Okay. And this is where the term hypervisor comes from, right? Because a hypervisor is really a supervisor of supervisors. Okay. Right. So hypervisor. So ring 0, that's where the kernel is running. That's where the highest level of privilege, like direct access to the CPU. And then, moving on out from those rings, there's less and less privilege to where your applications that you install and run on your OS, those are running in ring 3. Mm-hmm. Right. So with virtualization, with VMs, the hypervisor is going to be occupying ring 0 of the CPU, right? Which, makes sense. It has to, right? It needs the highest level of privilege. But this kind of now gives rise to a bit of a problem, because your guest operating systems, those kernels, they're written explicitly to run in ring 0, right? But they can't because the hypervisor is running in ring 0.
Okay.
So they can't be in that. So how do we? So we need some way of dealing with this, right? And this again is going to be, this is one of the key things of how the virtualization happens, what the hypervisor is doing, and the interaction between the guest OS and the hypervisor. So we have to deal with these guest OS kernels that were designed to run in ring 0 that they can't. Like, how do we bridge that gap? And so there's basically three broad ways of dealing with this. So one is full virtualization. And with this, the hypervisor is providing CPU emulation to handle those ring 0 operations made by the guest OS kernels.
Okay.
So this is complete emulation of the CPU, right? So that requires both time and resources. It's kind of the easiest in the sense that the guest OS kernels, they don't have to know anything different, but because it's complete emulation of the CPU, the performance isn't great, right? This is like the worst performance you can have, right? Because you're just completely emulating the CPU. It's not hardware, right? So that's full virtualization, and that's how things first started off. So then we need some techniques like, okay, we need better performance than that. Like, how are we going to deal with this? And so this leads rise to the other two techniques. One's called para-virtualization, and the other one is hardware virtualization. And so para-virtual is, and you may have seen this, like sometimes if you're launching EC2s, you'll see options there for PV versus hardware virtualization on your EC2, right? You may have seen this, just mentioned in passing, and it's like, what is that? So
right.
This is what it exists for, right? It's that problem of you have a virtual machine. The guest OS needs to be running in ring 0, but it can't. So how do you do that? And so para-virtualization, what it is the hypervisor provides an API that allows the guest OS to make calls into those API when it needs to run ring 0 operations. Okay. So the good thing, right, performance-wise, is like it's no longer doing the full emulation of the CPU. Mm-hmm. The operations that need to be running at ring 0 do run at ring 0 through these hyper calls to the hypervisor. But the downside is that the guest OS has to be modified, right? It has to be aware of this.
Yeah.
So the guest OS has to make changes to its code to say, instead of making these ring 0 direct calls, I instead have to make these hypervisor API calls.
Oh, interesting. Okay.
Right? So that's para-virtualization. So good performance, but the bad thing is like you got to go change code. Right. There's limited, compatibility there. Right. You have to have a guest OS.
So that would be like the guest OS, like Microsoft Windows or Ubuntu or whatever, has to be capable of doing this.
Mm-hmm. Yep.
Mm-hmm. Okay.
Yep. Absolutely. It has to be aware of that hypervisor and know that it's running in that environment. And again, replace those. When it would have normally done those ring 0 calls, instead it's making these hypervisor API calls.
Okay, got it.
So that's para-virtualization. And then the last one is hardware virtualization. So what this is now the CPU itself has hardware virtualization extensions built directly into the chip. And so this started happening in 2005, 2006. Both Intel and AMD added this to their CPU chips, and basically added a bunch of new instructions that allow for these guest OSs to run what normally would have been ring 0 operations in using these new instructions, right? That it's so the actual virtualization support is coming from the chip itself to do these things. So these new instructions, they permit the entering and exiting of a virtual execution mode.
Okay.
So the guest OS thinks it's running with full privilege at ring 0, but it's not, right? It's carved out, and the host OS is still protected. So the true ring 0 is protected, right? By running these new instructions. So the good thing with this, your guest OS doesn't have to have any modifications, right? So it doesn't know any better, but the performance is great because you're not doing emulation. You're running directly on the chip you're directly on the CPU.
So are you saying the hypervisor is like, okay, chip, gonna hand off instructions now for a bit to VMA, let's call it, and the chip's like, all right, go for it, I'm ready, and then VMA starts making calls to the chip as though it normally would, and the chip is like, yep, you're who I was expecting to be making these calls. Go ahead, I'm doing these operations for you, until the hypervisor is like, okay, I want it back. I want my access back. No more virtual mode, and I'm going to do my own stuff again. Is that kind of how it works? Do you think?
I mean, you probably can think of this as just it's actually creating a new ring above ring 0 for the hypervisor, and so that's essentially what this is enabling. So the important thing here is you're carving out that protected ring of core privilege to only the hypervisor, and the guest OSs have some amount of protection so that they can't pollute that. And so these instructions are essentially creating a ring above 0 for the hypervisor to run in. Okay. A lot to unpack.
Yeah, it is a lot to unpack. And, we could go on and on because then I start to have questions about what exactly is getting protected, and kind of I want to think of it in terms of examples a little bit. I don't know if you would be able to kind of give me an example of of a sequence of events that might happen, but if you could, that would be awesome. If not, we'll save it for next episode.
A big part of this, and doesn't have to do with necessarily with CPU instructions, but it's also address space too, right? So like carving out that virtual address space so that these VMs have their own isolated address spaces, right? So but
that's confusing in and of itself too, right? Because it's like, well, if the chip is the thing that's supporting if it's supporting the virtualization, and I guess that there's like registers, which are very limited, and maybe that's the address space you're talking about. But then there's also like the memory, which you can put in and pull out, and there could be 4 gigs, 8 gigs, 16 gigs, 64 gigs, terabyte of memory. That also has address space, and I wouldn't think that the chip would know anything about that.
No, yeah. So that, and the CPU does know about that, right? So those are. And that's kind of what we're talking about here. This is the
It does know about that. I thought that was the operating system's job to kind of know about that stuff.
The CPUs have direct support for that, and then the OSs they're allowed to they have to allocate that, right? But something has to control the access to that, right? Something has to talk to the memory chip. And so it's going through these CPU instructions to do that. So there's CPU specific capabilities dealing just with this that makes virtual machines safer and protects it, right? So with Intel chips, it has something called extended page tables, EPT. So this is part of that page table virtualization. So this is dealing with like the memory that we think of, right? When we're saying my application needs a gigabyte of RAM, right? That memory is expressed as pages of addresses. And so the chip itself has support, right, for having these virtual address spaces that are isolated from each one of these VMs, right? So there's that going on. There's actual operations, CPU operations that are added to it to kind of give us that ring above 0 for the hypervisor, so that we're making room for ring 0 for the guest OSs, but again, without overstepping their bounds and not causing like a blue screen of death, right?
Right, yeah.
So it means that you can blue screen of death in the guest OS. It's running in what it thinks is ring 0, but it doesn't bring down the hypervisor, right? That's that kind of like the isolation there that we're talking about that it's doing.
Yeah, super fascinating.
Yeah, so that, I think, that's a good foundation for like, okay, virtual machines, full virtualization, hypervisors, the two broad types of it, kind of going deep into the type 1 hypervisor, since that's really what's powering the cloud, and then talking a little bit about, okay, well, how does the guest OS actually access the hardware, and some of that virtualization take place through these rings of privilege, and the ways to get around this problem of like hypervisor needs to run a ring 0. How did the guest get access to ring 0? And that's where we talked about emulation and paravirtualization, and then the actual hardware support for it. Maybe that's a good place to leave off today. Next time we can kind of dive in a little bit with some actual implementations of hypervisors. So we'd like to talk about Hyper-V and its architecture, because it's really kind of interesting, and I think it'll actually help really bring to light some of this stuff that we've talked about here. Talk a little bit about KVM, which is Linux's kernel-based virtual machine extensions, which is very important, and this is actually where a lot of the technology is going to today, especially in AWS. And then we can kind of talk more about just AWS and its history of hypervisors and what it does. So when you're spinning up an EC2, what are the options there for hypervisor, and how have they been addressing performance? So they've actually been going down the route of making custom ASICs to deal with some of this stuff and to make it faster. So we can talk about that as well.
Cool, I can't wait. And already I'm feeling better about this. I'm feeling like I have a better foundation than I did in episode 1. So thank you very much, Chris.
Awesome.
All right, talk to you next week.
All right, we'll see you.
Nobody listens to podcast outros. Why are you still here? Oh, that's right. It's the outro song. Come talk to us at mobycast.fm or on Reddit at r/Mobycast.